So for example 1c, again, we have the definite integral here. Again, we can pull the constant of 2 out, so I can write this as 2 from 0 to pi over 6 cosine of 3x dx. So I am going to have to do a u sub because, again, I have that 3x inside my trig function. So again, I'm going to let u be equal to 3x. My du is 3 dx. So again, here is the dx. So to solve for dx, I'm going to divide by 3. So du over 3 is equal to dx. So when I rewrite my integral in terms of u, I'm going to have my 2 times the cosine of u times du over 3. So I can pull out that 1/3, so my coefficient is going to be 2/3 times my integral of cosine of u du. So now, because I did change my integral in terms of u, I need to change my bounds. So again, I'm going to make my t-chart. So my bounds in terms of x are pi over 6 and 0. So I need to take my pi over 6, plug it in for x into what u is equal to. So 3 times pi over 6 is pi over 2. When I plug in a 0, 0 times 3 is 0. So now my bounds in terms of u are going to be 0 to pi over 2. So again, when I integrate cosine of u, that's going to be equal to 2/3 times the sine of u. And again, I need to evaluate this from 0 to pi over 6. Excuse me, pi over 2. So when I will plug in pi over 2, I know the sine of pi over 2 from my unit circle is 1, so I have 2/3 times 1. Minus, when I plug in 0 from the unit circle, sine of 0 is just 0. So my answer is going to be 2/3. So if I take a look at the next one, again, this looks a lot like it could possibly be an inverse trig. Again, remember that 2x, that is a squared exponent. So I am going to do a u sub. I'm going to let u be equal to e to the negative x. My du is negative e to the negative x dx. So again, there's that e to the negative x dx. So I am going to have to divide out a negative, so du, negative du is equal to e to the negative x dx. So I can rewrite this integral as my negative. Again, I have that 1 over the square root of 1 minus u squared du. So now again, I need to change my bounds in terms of u because I changed my integral. So again, when I change my bounds, right now when I make my t-chart, there's x and u. So right now my upper bound is the natural log of 2 over square root 3. My lower bound is the natural log of 2. So again, I need to substitute these back into my equation to solve for u. So again, I'm going to replace, it's going to be e raised to the negative natural log of 2 over square root 3. So remembering your properties of logs, again, you've got to move this negative sign to be the exponent. So this is equivalent to e raised to the natural log of square root 3 over 2, which is just going to give me square root 3 over 2. Then I also need to substitute natural log of 2. So I have e raised to the natural log of 2, which is equivalent to e raised to the natural log of 1/2 using your power properties of logs. So e raised to the natural log is going to be 1/2. So now I have my new bounds. again, my lower bound is the 1/2. My upper bound is the square root of 3 over 2. So now I've got, this is my integral for my inverse sine. So I have my negative inverse sine of u. And again, I need to evaluate this from 1/2 to square root 3 over 2. So negative inverse sine of square root 3 over 2 minus, now be careful, it's another negative, negative inverse sine of 1/2. So from the, remembering your inverse values, your inverse is square root 3 over 2. That's going to be at pi over 3. So I have negative pi over 3. This turns into a plus. The inverse sine is going to be pi over 6. Inverse sine of 1/2, remember, is pi over 6. So I have negative pi over 3 plus pi over 6. So looking at another completing the square, if we look at, again, we're going to do an example like number 3 on Tuesday, but if we take a look at number 4, we have, again, the definite integral with dx divided by the square root of 6x minus x squared. Again, we cannot factor that denominator, so again, I am going to have to work on completing the square on that denominator to help me set up one of my inverse trigs. Again, remember, in order to complete the square, the coefficient of x squared needs to be a positive 1. So I'm going to rewrite this as an x squared minus 6x. So when I complete the square, that's negative 6 divided by 2 squared, which is a 9. Now remember, you didn't actually add 9, you subtracted 9. So on the outside, to keep this denominator equivalent, I'm going to add that 9. Now I can write this as a binomial squared. So I have the negative x minus 3 squared plus 9. Or remember, to set this up as my inverse sine, I'm going to write this as 9 minus x minus 3 squared. So now again, I have 1 over the square root of 9 minus x minus 3 squared dx. Remember, in order to do inverse sine, this has to be a 1. So I'm going to have to factor out a 9. So it's going to be 9 times 1 minus x minus 3 squared all over 9. So now 1 divided by square root of 9, I can pull a 1/3 out. And I have to write this as a base to the second power. So now I need to do a u sub. Again, I can do the u sub right here. So u is equal to x minus 3 over 3. My du is going to be equal to 1/3 dx. Or 3 du is equal to dx. So now again, when I rewrite this, again, 3 times 1/3 is just going to give me a 1. So again, I've got 1 over the square root of 1 minus u squared du. Now I did do a u sub. This is a definite integral. So again, I need to change those bounds. So in terms of x, my bounds are going to go from 0 to 3/2. So when I plug in 3/2 for u, 3/2 minus 3, so 3/2, that's going to be, that's going to be 3/2 minus, so that's going to give me a negative 1/2. When I plug in a 0, that's going to give me a negative 1. So now my new bounds are going to be from negative 1 to negative 1/2. So now I'm ready to integrate. So I have the inverse sine of u, and again I need to evaluate this from negative 1 to negative 1/2. So my inverse sine of negative 1/2 minus my inverse sine of negative 1. So from the unit circle, remembering your inverses, inverse sine of negative 1/2 is negative pi over 6. inverse sine of negative 1 is going to be a negative pi over 2. So minus a negative turns into a plus. So we have negative pi over 6 plus pi over 2.